Hello everybody, welcome to our 4-3 and 4-4 section. We're going to do this in 2 days, but it's 2 sections. So we're combining them but doing it still over 2 days. So today is going to be day 1 of triangle congruence. So to prove the 2 triangles are congruent, you got to prove one of the following. So the first one is simply prove every side and every angle is congruent. That's what you guys just finished in 4.2. But you don't have to do that for every single situation. 2 is side, side, side. We're going to work on that one today, and that's in 4.3. So we're going to do that side, side, side today, and also we're going to do side angle side today, SAS. That's from 4.4. Then we'll do day 2, we'll do hypotenuse leg, HL, and that's from 4.4 as well. So the SSS, side, side, side congruence postulate, states if all 3 sides are congruent, then the 2 triangles are congruent. All right, so if we get that, we have SSS. So to prove SSS, you'd want to notice all the markings, and we'd have a side, and a side. Now in this case, if we take a look at AB, that is exactly congruent to RS. So I would say then segment AB is congruent to RS. All right, and that also means that angle A is congruent to angle R, because when if the triangles are congruent, that means every part of the triangle is congruent, all sides and all angles. All right, and then if I went to the next one, if I did BC and ST, notice those are exactly the same. So in this case, for side, I would say BC is congruent to ST. And then we check the last one. Now you could do CA, which would be TR, or you could do AC, which would be RT. Either one of those, this last side, we would say AC is congruent to RT. And the last thing we want to do is we want to make what's called a congruence statement. And a congruence statement is just exactly what we figured out. Because of SSS, we now know that triangle ABC is congruent to triangle. Now when you make your statement, you have to make sure that the corresponding parts line up. So A went with angle A is the same as angle R. So then I'll say R, and B, S, so then S, and then C went with T, RST. All right, we'll keep working on those congruence statements as we go, but that's the basics of the side, side, side congruence postulate. The next one today is called side angle side, okay, and that's if 2 sides and an included angle, included is the big word right there, are congruent, then the 2 triangles are congruent. So first off, let's take the word included, okay? So what is an included angle? That is going to be an angle that is between 2 congruent sides. So looking at our picture, notice angle R and angle U are between this side, which is congruent to this side, and this side, which is congruent to this side. That is an included angle. If it's not an included angle, it's not SAS, because then the A is not between the 2 sides. All right, so we'll talk more about SAS and the angle in a little bit, but same kind of deal. We want to just go, okay, I have a side, I have an angle, and I have a side congruent. And if you look at the picture, take a look at it, how I start on this side and I go side to angle and then to side, all in one swoop. All right, I can't go from this side around there to get that same thing. It has to be from, or I could go from the green around this way. So notice I have to go in a circle to make sure that it works out. So in this case, the sides are, I first started with RT is congruent to UW segments. Angle, in this case, I can say angle R is congruent to angle U, because there's only one angle at R and U. And then I can say angle or side, I'm going to go with SR this time. Now if I went SR, I have to say VU on the other one, because S corresponds with V. There's my angle, side, sorry. Now we're going to make our congruent statement again. So in this case, we'd say triangle. And if I say SRT, that has to be congruent to, remember, because S and V, then I would say triangle VUW. And now we're going to take a look a little closer at this included angle information. So as I said up here, notice it says the A in SAS must be included angle. So it must be a side, and an angle in between the two sides. All right, so side, then it would be that angle is included. If I had side, then that angle is included. All right, so notice I can't use, if I finish off my triangle like that with that line, I can't use that angle or that angle. Notice marking, the angle must be between the two marks. So here's a better picture right here about this. So notice that the angle is right there, is between the two known sides. All right, here's an example where the angle is not between the known sides. So if you look here on this one, it's a side right there, an angle, and a side in that order around like that. Or I could have done that order around there. All right, if I look down below, notice I have a side, and an angle here. Notice that is side, open angle, side. Okay. I'm not going to show you how it goes around the other way, because look what that would spell. All right, so we got to make sure that we don't have that. So again, side, the angle has to be between it and another side. We cannot have SSA, because if you look backwards, what that would spell. So here are some examples. Are the two triangles congruent? If yes, write a congruent statement. So here you look at the triangles, and one thing you might notice is that the triangles are right on top of each other. So sometimes it's a great idea to rewrite the triangle. So there's one triangle. All right, if I brought it over here, I could say then that is angle ABD. And then if I trace the other triangle, it would be this one right here. All right, if I brought that triangle down, that's triangle D, B, and C. And we can mark them. This is congruent there. This one is congruent. And now looking at the triangles, some of you might have noticed right from the start that this line right here is the same in both triangles. Notice I have DB and DB, same one. So that is in fact the third set. There is another set of congruent marks I could put in both pictures. Okay, so let's work through this. I have side congruent, and now let's look. I have AD right there, and that is congruent to, now notice, A to D. All right, D is part of this middle side, whereas A is part of the other sides. Whereas now if I go over here, I can't just simply say, I don't know, is it BC? But notice I went from kind of this almost looks like a right angle. A kind of looks like a right angle, but it's not. But so I have to go C to B. So A corresponds with C, so I'd have to write CB in that order. All right. And then if I went to my next side, I knew that it was CD, so I went from the red line to D, so from the red line over to B. So that case, I had AB up top, right there, A to B, and that's going to be congruent to CD. And then lastly, my other side, which I had in here, I'm going to go from there. So if I went from B down to D, I write BD is congruent to, and now if I went from the blue line to the red, All right, that means I started here at the blue and went to the red. Then I'd have to write DB for that to be the true congruent statement. All right, and so now to write my congruent statement, I would say triangle, and if I went ABD first, is congruent to A is red and blue, so C is red and blue, triangle C. If B is blue and green, then D is blue and green, so CD, and D is red and green, so B is red and green, so then B. There is my statement, there is my work, and there is my statement to prove that yes, they are congruent, so my answer should be yes. Triangle ABD is congruent to triangle CBD. So another example, are these two triangles congruent? So I'm looking at triangle LMN and NOP. All right, so are they congruent? Well, we can go through the marking. So I'm just going to start at one of them right here, this marking. That is marking a side, and that is marking that side MN, all right, is congruent to OP. And then if I work my way around from that one, I work my way in a circle to get to the next one. I end up at an angle right here. Now look at this value. How many different angles are in that position right there? Okay, notice there's multiple angles there, so I cannot use angle N as a statement. I have to be more specific with my angle. So in this case, my angle is going to be angle MNL would be congruent to, and since I used 3 angles, that's a better angle symbol, and since I used 3 letters, I'm going to use it for this one as well. And I went from M, so that's going to be O, angle O, and then P, and then N. And then I have another marking, which is right here, or right there, and that's going to be NL, so I would write side, and I go NL would be congruent to, and then if I went from N to L, that means I got to go from P angle to side, so then side PN. All right, so now I have SAS. SAS does work because the angle is included. All right, so notice I had this side with this side, and notice that the angle is between the two sides, so it is in fact SAS, and not the angle being outside of it. Then it wouldn't work. If the angle is inside of the two sides, it does work. And now I will make my congruent statement. I write yes, they are congruent, triangle. And if you look at if you use 3 letters for your angles, that should end up being the triangles too. M and L is congruent to triangle OPN. There we have it. Yes, they are congruent. This one is done. All right, so here is the next example, and this is one just like the other ones. Our next example will be slightly different. So in this case, notice I don't have congruent markings, all right, but I do notice that I have this length of 10, and I also have this length of 10. Well, if they both have the same length, then those are sides that are congruent. So I could say side, and I would say AB, all right, and now A is off by itself, B is up top to the 10, so I went from the flat side to the high side is congruent to, then I'd have to start over here and up, so then that would be DE is the other side. All right, and now notice I also have this segment here that is 8, and this segment here that is 8. Well, if they're the same length, those sides would be congruent. So if I said side AC would be congruent to, so I would start over here and went that way. So then I have to start at D and go to F, so then DF is the other side. And now the question is, are the other sides congruent? Okay, well notice that segment in the middle here, this BF is actually going to be a congruent statement to each other. So I have this segment BF, and in ABC I go down a distance of 2 to get the other side. So I have a congruent segment to 2, And then the other way, I have that congruent segment and also 2. So that means that if I have an equal length and I add 2, and an equal length and add 2, those two segments will be identical. So then I could say side is also congruent. And if I said side CB, all right, I went from out and up to the top, then I'd have to say that's congruent to, well, then that would be FE would be the other statement. And then SSS, that proves congruence. So yes, they are congruent. And the statement is triangle ABC. And notice A went with D, B, E, C is with F. So then that's congruent to triangle D, E, F. Slightly different question now. So here I'm giving you triangles, and I'm telling you that I want to prove them congruent by SAS. So I ask you to state what additional information is required to know that the triangles are congruent because SAS. All right. So if I have SAS, that means I have to have side, angle, side. And I have to have it in that order. So if I have this segment that's congruent, and if I have this angle that is congruent, well then that means I would have to put it at this side would be the other congruence. All right. Otherwise, I would not have SAS. So right here I have a side. Here's an angle and a side. Notice that it's S between S. A is between S and S. If I put the other S on this segment right here, notice there it's not a very good possibility to go between those words. So it can't be SSA, has to be SAS. Now looking at the other triangle, I have this segment congruent. This angle is congruent, so B and A, which means I would then have to go with this segment to give me the other S. So what do I need to prove congruence? I would need segment AR to be congruent to, now notice for AR, I went away from the angle into the angle. So on this picture, I'd have to go away from the angle into the angle, so then that's going to be CB. So all you need to do here is just tell me what other information do I need to prove SAS, and that's just that segment has to be congruent. Same idea here. I want to just figure out how do I prove them by SAS. Well, again, I'm given a side right there and a side right there. All right, I need to find an angle that's congruent. Well, if I look at angle C right in that region there, notice that I would have vertical angles right there and right there. So that'd be angle BCA, right? BCA right there is then congruent to angle ECD. And if I want to prove that it's side, angle, side, there is my angle, then I have to go side right here. That side has to be congruent. Again, SAS. Here's my angle, SAS right there. So what has to be true in order to prove it's by SAS? I'd have to say segment AC is congruent to, and I went from outside into the angle again. So outside into the angle, then DC is my statement. That is what has to be proven. And now if that is true, if this is true, if this statement is true, the triangles are congruent by SAS. All right, last example here. So same thing, I want to state what information I need to prove that it's congruent from SSS. So now let's look at what information I do have. I know that I have congruent segment there and congruent segment there. So I have AE is congruent to CE. And then also consider that these triangles share a side. So then that side is congruent to itself. So BE is congruent to BE. And if I want another side to be congruent, I'd have to use this side, has to be congruent to that side. So I would have to say segment AB is congruent to segment CB. Now that if that was congruent, the triangles would be congruent because of side, 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 and we have it. So this is the end of our video, and this is the homework assignment. You'd find it on Schoology. Good luck. Have a good day.